Hello everyone. In my last video, I already explained you about the half-wave rectifier and I told you that today we will discuss full wave rectifier where you can see that this positive half cycle and negative half cycle both will be rectified together. Okay, and we will get both the wave together in the output waveform. Okay, so our today's topic is full wave rectifier, and in that full wave rectifier, we will discuss about the bridge rectifier and center tap rectifier. Okay, our first topic is bridge rectifier. Okay, so this is the circuit diagram of a bridge rectifier. Okay, where you can see we have four diodes connecting together, and it creates a bridge, right? That's why you call this one as a bridge rectifier, as these four diode connected together and create a bridge shape. That's why it called as a bridge rectifier, right? So this circuit also looks like Wheatstone bridge. That's why it's called as a bridge rectifier. Okay. So if I explain you directly about this circuit operations, then it will be a little bit difficult for you. Okay. So I will start from the half wave rectifier and ultimately I will explain you the bridge rectifier. In my last class, I already explained you about the half wave rectifier where we use a single diode with a AC voltage source and a load resistance RL, right? And with this circuit, if this is the input waveform, then in the output we get this waveform, right? Where in this positive half cycle we get the output waveform, but in the negative half cycle we didn't get any output. So the input is looks like this one, right? That's why we call it the half wave rectifier, right? And I told you that we need a waveform like this. Then how to draw that particular circuit such that we will get this kind of waveform, right? The circuit will be looks like this. Just the direction of the diode will be reverse. Others, everything will be the same, right? As we don't need any output for the positive half cycle, that's why you can see that for the positive half cycle, this is plus, this is minus, right? And for this circuit, you can see that this is V1, this is V2, right? So V1 is negative, V2 is positive, right? That means V1 is greater than V2. So this will be reverse bias, right? So in the positive half cycle, this diode is in reverse bias. So it will act as a open circuit. So no current will flow from this circuit. That means we will get zero, right? And for the negative half cycle, this will be positive, this will be negative. That means this diode will be in the forward bias and a current will flow from this side, right? So this will be the circuit. Okay. So now if I just do a little bit more with the first circuit, then suppose we have here one diode, right? If I connect another diode in this particular circuit like this, if I do this one, a diode is here, okay, a resistance, and I connect another diode in this place, right? I think you understand this circuit and this circuit will behave similarly, right? Why? You can see that this is P, this is N, this is P, this is N. When this is plus, this is minus, then both this diode and this diode will be in the forward bias, right? So the current will pass like this, okay? And if this one is plus and this one is minus, at that time this diode D2 and this diode D1, both D1 and D2 will be in the reverse bias, right? When this two diode is a reverse bias, then this will be act as a open circuit, so no current will flow from the load resistance, so we will get zero output voltage, and in the positive cycle we will get the input voltage. Okay, we assume that this two diode is ideal diode. Then if this voltage is V, then this voltage will also V. And in my last video I told you if this diode is a practical diode, then this potential will be V minus 0.7 for one diode, right? Here you can see we connect two diode, right? That means this potential will be V minus 1.4. Okay, so why 1.4? As we need to consider both diode voltage drop. Okay, so I think you already understand. If we connect two diode, then this circuit also act as a half wave rectifier. Okay, so if we go to the next one, what I did, I just redraw the circuit such that you can see this diode is just in a 45-degree angle. Okay, and then you can see it connected with the resistance. Okay, and then again it connected with the diode PN, right? That means this circuit and this circuit is exactly same, right? For this one, if I explain you again about the principle of this circuit, then for the positive half cycle, this will be plus and this will be minus, right? That means here it will be V1, it will be V2, and here it will be V1, this will be V2, right? So you can see here, if a current will flow from this direction, then the current flow will be like this. That means this diode will be in the forward bias, current flow will be like this. Current will flow from the with the resistance, then with this diode, and then go back to the source. Okay, so this will be the direction of the current flow, right? If we call this diode D1 and this diode D2, then we can say for this particular half wave, D1 and D2 both is in forward bias. Okay, so we will get the output waveform will be exactly follow the input waveform if the diodes are the ideal diode. Then we get the same output voltage. If this is V, then we will get here V. Got it? Okay, no issue. Now, what will happen for the negative half cycle? For the negative half cycle, this point is plus and this point is minus. That means a current will try to flow from this direction, right? When the current will try to flow from this direction, you can see this one. This is N and this is P, right? That means diode will block that particular current from N to P, right? As this will act as a reverse bias. Why? In the reverse bias, how the circuit looks like? The N of the diode is connected with the positive part of the voltage source, right? Just same as this one. Here you can see the positive part is connected with the M side, right? That means this diode will be in the reverse bias. So for the D1 diode, you can see here P terminal is connected with the negative terminal of the voltage source. That means this is same like this one, negative terminal of the voltage source connected with the P side, right? That means this D1 is also in the reverse bias. Okay, so for this circuit, for the negative half cycle, both D1 and D2 are in the reverse bias, right? As this circuit is in the reverse bias, that means here there will be no current flow. Why? As this will act as a open circuit. So we will not get any output in the negative half cycle, right? So that means for the positive half cycle, we already have the output voltage, and in the negative half cycle, it will be 0, right? So this is exactly the same concept with the half wave rectifier, but here what I did, I just used a two diode, not a single diode. In last video, I used a only this particular diode and the resistance, right? Here what I did, I just connect extra one diode, and I just show you that the circuit operation will be exactly the same, right? And I already told you that if I need a waveform for the negative half cycle, suppose for the positive half cycle is 0 and negative half cycle we have the output waveform, then how the circuit will looks like? Voltage source, the diode will be in the opposite direction, right? This is for the simple half wave, right? And we call it as a D3. Okay. For the negative half cycle, this will be plus and this will be minus, and a current will flow from this direction, right? That means the direction of the current flow will be this side to this side. What if I connect a diode in this particular circuit such that the output will be same, right? How to connect that diode? If I connect a diode like this, then you can see here the positive is connected with the P. That means this will be forward bias, right? That means the output waveform will be exactly same with the previous circuit, right? The output will not change. Okay, so here you can see I use two diode D3 and D4 with the same resistance RL, then also we get this waveform, right? So if I redraw this circuit like this, here you can see this is the plus and this is minus, right? And this one you can see directly goes to the diode P side, N side, and then go to the resistance part. After that, it will go to the this diode and come back, right? And we call this diode is D3 and D4, right? That means D3 and D4 are both in the forward bias for the negative half cycle when this is plus, this is minus, right? That means we will get a positive waveform, right? And positive half cycle, what will happen? This is plus, this is minus, right? That means this is inside P, P, N. I already told you the concept of the reverse bias will be the diode N side will be connected with the positive part or diode P side is connected with the negative part, right? Here you can see for this particular diode, the positive part is connected with the inside, okay? And for this diode, you can see the P part is connected with the negative side. That means this diode D3 and this diode D4 both are in the reverse bias for the positive half cycle. That means we will get zero potential here for the positive, and for the negative we already have this one, right? But you should have one question for this circuit. I already explained you that this will give us the output in the positive half cycle, right? But in the negative half cycle it is zero. So you can see for the positive half cycle, it is exactly follow the input voltage. But in the negative half cycle, you can see this circuit is not follow the input waveform. It's just opposite of the input waveform, right? And this is in the single side, just as the positive half cycle. Why so? See this waveform. Suppose for positive half cycle, this is plus, this is minus, right? Then a current will flow from this direction to this direction to this direction. This is resistance R, this direction, like this, right? Go back to here. For this is a positive half cycle, right? Now you can see I current is flow through the resistance from A point to B point, right? That means the polarity of the voltage will be this side plus, this side minus, right? So we can write down VAB equal to plus IR, right? Or it will be exactly equal to V high when these two diode is a ideal diode, right? So polarity is plus and minus. That means we exactly get the input waveform in the output. Okay. And now go to the reverse bias circuit. Here you can see the direction of the current is this side, then this D3 diode, resistance, and then coming back to the source, right? For this one also you can see the load current is flow from point A to point B, right? And we all know the Ohm's law that if a current is flow through the resistance R, then the voltage without polarity will be this side plus, this side minus, as current is always flow from higher potential to lower potential. That means this is plus and this is minus. VAB is equal to I multiplied by R, right? And here you can see this is plus, this is minus, right? But here you can see the VI is this side plus, this side minus. That means we can write down minus of VI, right? As you can see, minus plus plus minus. That means the direction is opposite. So it will equal to minus VI. That means we will get the output will be opposite of the input voltage. That's why we got the waveform in the positive side. Okay, and in the positive half cycle it will be 0. Okay, I already explained you two types of circuit where the first circuit will give the output for the positive half cycle and the second circuit will give the output for the negative half cycle, right? That means this one for the positive half cycle and this circuit is for the negative half cycle, right? Now just connect these two circuit and you can see here, if I just connect these two circuit, it will form a bridge rectifier, right? You understood? That means this part of the circuit will handle the positive half cycle and this part of the circuit will handle the negative half cycle. And if you combine these two particular circuit, then you will get the full bridge rectifier. Okay, where the output will be for this one will be like this and for this one will be like this, right? So if I just add these two, we will get a full wave rectifier. You understood why I didn't start with the directly from the full bridge rectifier? As if I start with the full bridge rectifier and if I tell you that this is forward bias, reverse bias, reverse bias, you will be in the puzzle. You will not understand completely. That's why what I did, I take two half bridge rectifier and connect it together to form a full bridge rectifier such that you will understand properly. As if you study the half wave rectifier, you will understand that two half wave rectifier will connect together and form a full wave rectifier. Okay? So now I will explain you the completely full bridge rectifier. So for the positive half cycle, this side is plus, this side is minus, right? And this is D1 diode, this is D2 diode, this is D3 diode, this is D4 diode. Okay? So when this is plus, this is minus, then a current is flow from this side and it come to the here, right? Now the question is, which side the current will flow? This side or this side? The current will flow this side, not this side. Why? You can see here, for this diode, this is P, this is N. For this diode, this is N, this is P, right? That means the positive of the voltage source should connect with the P side to form the forward bias, right? So you can see, for this case, D1 will be in the forward bias and D4 will be in the reverse bias, right? Understood? So current will flow from this point to D1 to this side, right? Now you can see the current already reached in this particular point, right? Now the current have two options, go this side or this side, right? Now for the D3 diode, this is N, this is P, right? But a diode will not allow a current will flow from N to P. Diode will not allow this one, right? Okay, so what will happen? The current will flow from this side and flow through the load resistance RL. Okay, and then it come back to here and here. Then the current will come in this point, right? Now I already explained you D4 is in the reverse bias, right? So it have only one way. Which one? D2. So here also D2 is in the forward bias. I already explained in the last slide, and then it go to the source. Okay, so you understand the current flow mechanism in the positive half cycle. So we will get the output waveform will be same as the input waveform when D1 and D3 diode is the ideal diode. Okay, so for this one, D1 and D3 diode is conducting for this half cycle. Okay, now go to the negative half cycle. For the negative half cycle, this will be plus, this will be minus, right? So current will start flow from the source and it will go to this particular node. Okay. Now current have two options. One, flow this side or flow this side, right? But here the same concept. For the D3 diode, this is P, this is N, this is N, this is P for the D2 diode, right? So here in this case, D2 diode is in the reverse bias as the N terminal is connected with the positive. So this diode will be in the reverse bias, okay? And this diode will be in the forward bias. So this is forward bias and this will be reverse bias, okay? So what will happen? The current will flow from the D3 diode and come in this line. Now the same case, this is the D1 diode and here in the D1 diode, the current will not flow from the N to P, right? as diode will not allow to flow the current from the N to P, right? That means this will be also in the reverse bias. Or if you didn't understand this one, just think like this. This is negative, right? And negative terminal is connected with the P side of this D1 diode. That means this diode in the reverse bias. Okay? So current don't have any choice, right? So current will flow from this point to the load resistance and this side and go to this and this side, right? Now we can see this D2 diode is already in the reverse bias. I already explained you. So what will happen? The current will flow from the D4 diode, as D4 diode will be in the forward bias. Why? You can see negative terminal is connected with the N of the D4 diode, right? So it is forward bias and then the current will go back to the source. Okay? Here you can see this is R. The direction of the current flow will be point A to point B. This means this will be plus, this will be minus, right? That means the output will be same as the positive half cycle output. So this side. Okay. So here you can see for the positive half cycle, D1 and D2 is conducting. For the negative half cycle, D3 and D4 is conducting. Okay. Where this diode is D1, this diode is D1, this diode is D2, this diode is D3, this diode is D4. Okay, so I just summarize again. For the positive half cycle, this will be plus, current will flow from this direction, this direction, this direction, this, and come to the source. Okay, this is for the positive half cycle. For the negative half cycle, this will be plus, this is minus, current will flow from this side, this side, this side, and then come back to the source. Okay, so you already understand the concept of the bridge rectifier. Okay, if you didn't understand this concept yet, I request you please see the video again. Okay, as this is not that much easy concept, but I try to explain you by breaking the circuit. Okay, don't try to analyze the circuit directly with the 4 diode. Try to analyze the circuit with the 2 individual diodes for the 2 half cycles. Okay, so this is all about the bridge rectifier. So let's do the simulation, okay, and see how the circuit behaves. Here you can see this is the 50 Hz AC voltage source, okay, and this is a voltmeter to read the input voltage waveform, okay, and this voltmeter to read the output voltage. Here you can see this diode is D1, this diode is D2, this diode is D3, this is D4, okay. So the positive terminal of the input voltage, you can see that it's connected between the D1 and D4, okay, and the negative terminal is connected between the D3 and D2, okay, and the load is connected between the D1 and D3, and negative terminal connected with the D4 and D2, okay. So you can check that one with my circuit diagram, it will be exactly the same. So let's simulate the circuit. Here you can see this is a practical diode, right? So there should be some voltage drop across the diode. So now you can see we are in the positive half cycle and current flow direction is through the voltage source, D1, resistance and D2, right? Just same what we discussed in the theory, okay? Now it will go to the negative half cycle and you can see it will change. Here you can see we are in the negative half cycle, right? And here you can see that it will be from the voltage source to D3 to resistance to D4, then source again, right? And here you can see that we get the full wave rectifier output, right? That means we get the both the waveform on the positive side. Okay, so you understand that for the positive half cycle, the D1 and D2 is conducting. For the negative half cycle, D3 and D4 is conducting. Okay, so I simulate this circuit and you can see the waveform and direction of the current flow. Okay, maybe I am slowing down that one, so it will be a little bit easier for you. So now is the negative half cycle, right? So you can see D3, D4 is conducting. Switch to positive half cycle. Now D1 and D2 is conducting. Okay. Now again switch back to negative half cycle. You can see D3, D4 is conducting. Okay, so this is all about the bridge rectifier. Okay, and I already explained you how this circuit works, right? That means I already explained you the half bridge for the positive half cycle, half bridge for the negative half cycle. Okay, so this is all about the bridge rectifier. Thanks for your time. Please do share this concept with your friends, and if you like this video, please press the like button. It is really means a lot for me. Bye bye.